Hello, welcome back. So this is fifth lecture for chapter 14 about generics. And in this lecture, we are going to discuss um, a generic implementation using array for our stack class. Okay, so basically we're kind of modifying the stack class that we previously designed um, and modify it to a generic class. Okay, so the example is Java generic stack example, and we have two files, a stack .java file and a driver. Okay, so let's take a look. Um, the stack class that use array as its storage for of the items. But this time, what we did is we designed this stack class as a generic class. Okay, so it's an unbounded one. So unbounded type. So a static, and we have the same as the stack class that we defined. We have an array to hold all of the stack items, and we have the top index to keep track of the top item where it is. And for this stack class, we also implement the clone method and the comparable interface and the iterable interface. Okay, and you can see over here for this iterable, it's generic type because our stack type is generic, so it's consistent also the same T. Okay, and for the comparable, the type is a generic stack type. Okay. So then let's take a look. And this time, the array type, then it's the generic uh, T type. Okay, so the type parameter is T, and it's generic. And because of the generic and for arrays creation, we cannot use generic to do to create memory as it on heap. And because Java is also a strongly typed programming language, so that's not going to work. So how we get around with it here is we use object. So we create an array of object, and then we cast it to the generic type. Because when we use the stack class to create instance, then we need to plug in the corresponding concrete class type, and then at that time we can cast it to whatever the specific concrete class type. Okay, so over here we do the cast. Okay, and because of this, and Java will, because Java is a strongly typed programming language, and so Java compiler then will issue the unchecked cast warning. Okay, so because of this, we add the suppress warnings unchecked, this annotation. Okay, so to apply this the suppression here because of the cast object array to the generic type T array. And everything else is the same here. Okay, so this is about the default constructor. And then let's take a look at the remaining implementation for this stack class. So here, this is the constructor that with parameter. So similar because we do the cast. So we have this annotation for suppress warnings. Okay. And over here, in this implementation, we also add a third type of constructor. We call it a copy constructor. Okay, so generally speaking, constructor categories or type, there are three type of constructor. One is a default one, so without a parameter. The second is explicit value, so with parameter. Okay. The third type is copy constructor. Copy constructor, the parameter is another object of the class type. Okay, so over here, the parameter, you can see it's another stack object. So over here, it's another stack object. Okay, and of course, over here, it's a generic one. Okay, so what we will do is we just copy the index and do the array copy from this other stack. Okay, and even though the copy here, it does have a deep copy of array, but not array elements. Okay, so that's why here we cannot say it's completely deep copy. It's just a shallow copy. Okay, so basically heap. Okay, so you have this. This is the other dot array, M array. Okay, and then you have a copy. Okay, so this is the M array. So it has its own location, but of the items, it's a reference to the items in the other objects. And if we wanted to have explicit copy of itself, then we need to do some other implementation. Okay, so that's over here, but here so just be careful. Okay, so this is about the copy constructor. So it's a new type of constructor that we learned. And the empty function implementation is the same. And for the push, because you're going to add an item, so the item, this implementation change, it's a generic type, okay? And what we do over here is if the stack not empty, we just directly assign it and increment the top index at the same time. Otherwise, if it's full, we are going to double our array. So then over here, we need to do the similar thing as the constructor, okay? So create an array and then do the copy. And for pop, nothing new here. For the pick, the difference here, the return type is the generic type, okay? And the toString, nothing new here. And for the clone, then what's the implementation here is we continue to use that array copy. Okay, so and over here we also implement, because this stack class implemented the comparable interface. So we needed to implement this compare to method from the comparable interface. And the parameter then is another stack. So we try to compare. We just use the size for comparison here. Okay. And for our stack class, we also implement the iterable interface. Okay, so that's why over here we needed to implement this iterator method. It returns a generic iterator, okay? And what we do is we create an inner class over here, okay? Nested inner class stack iterator. It implemented iterator interface. And we initiate the iterator index to the top. And we implement the has next method. And the next method, nothing new here. And what this iterator method is just create a new instance of this nested class that we just created. Okay, so that's about this stack, generic stack class. Okay, then next let's take a look at the driver part. Okay, so for the driver part, we first create a stack. It's an integer type. Okay, then we just add a 10 item to this stack. Then we try to search, and here we have two types, two version of the search item. Okay, and let's take a look at their implementation. So the first search item, and if we take a look, it's a general, it's a normal method, okay. Second parameter is the item that it wants to search. The first parameter, the type is a stack, okay. But this stack, it uses wildcards. Wildcards, okay, and it's a lower bound one, okay. So this wildcard can be number or any of its subtype, okay. So we use wildcards type here. Okay, and our implementation. The first implementation, what we try to do is we use a copy constructor to create a copy, okay? And then we just using the pop to do the check with each of the top item to see if we can find it, okay? But of course, we can see this implementation is not efficient because it involves copy the whole the stack. And also it involves a lot of pop operation, the pick, okay. So that's not efficient. And the second type of the search method over here it's more efficient, and the parameter it's similar as the first one. And over here, because our stack class, it implements the iterable interface. Okay, iterable interface. So what over here we do is then we can do the for each loop. For each loop, and then try to do the comparison. And the clean sentence, for what this method does is try to convert a sentence if the latter, okay, if it is a latter, then we are going to convert everything to the lower case, okay? And we are going to uh, create like a new string, okay? That's the cleaned. And from this sentence, we only take letter, so only letter or digit. Everything else, we are going to remove it, okay? And then for this reverse sentence, we use a stack to do the reversing. If you recall in the chapter of stack, we discussed, well, the advantage of a stack, it can be used to do the reversing. Okay, so that's about this example, and let's take a look at its running result. Okay. And the running result, what over here we did, we first try to search if the item is in the stack, and it says it. 100 is not in the stack, okay. And then to continue do some check, is it? And also do the stack comparison and also check if the sentence is palindrome. Okay, so that's all for this example. And that's all for this chapter. And in our next lecture, we are going to move to a new chapter. See you.